Buffer op-amp. Let's create a non-inverting buffer. And we can start off with a non-inverting amplifier. And if we let R1 equal infinity and R2 equals 0, and we plug that into our V out equation, 0 divided by infinity is 0, and we're left with V out equals V in. Now how do we set R1 equal to infinity? We simply remove it. How do we set R2 equal to 0 ohms? We simply connect a 0 ohm wire between out and this terminal. It's that simple. Now let's look at an inverting buffer. All we have to do is let R1 equal R2. If V out equals the ratio of R2 divided by R1 times minus 1, and we set them equal, then V out will equal minus V in. Again, it's that simple. But some things aren't so simple. This is not an inverting buffer. And here's why. R1 is 0, okay, and R2 is 0. V in is shorted to V out, and so it's not really buffering at all. V in, there's nothing in between V in and V out. It's just the same wire. And so it's not a non-inverting buffer either. It's just a short. Here's another not an inverting buffer, or almost a nothing circuit. I'm putting in V1 in on the negative terminal. You might have noticed that the negative terminal is always on the top and the positive's on the bottom in all my other examples. In this example, I have positive on top. And yes, I've got the power supplies correctly attached as well. We don't really have to get into much analysis, but using this V out equation is the open loop gain times the difference between V positive and minus V negative. Well, V negative is grounded at 0. Okay. So the open loop gain is just V positive. But V positive is shorted to V out. And so now I have V out equals the open loop gain times V out, which mathematically doesn't make sense. But in a circuit, there would be a delay between this and that. And there's capacitors in here that you can't see. So what would really happen is if V out starts at a positive number, this positive feedback will just keep driving V out up over time until it hits the limit. If V out should randomly start out at a negative voltage, it will fall to the power supply limit. So that not this circuit and this circuit, I see sometimes people trying to use them. Please don't. They don't work.